Hello everyone, we are Team H2O from Sri Ramakrishna Institute of Technology, Coimbatore. Our project title is Water Quality Monitoring Using IoT. The name of the inventors for this project is Mr. A.P. Roger Rosario, Vijayarada Surya and Saumitran.
Water quality monitoring using IoT. In a village full of healthy environment, there is a public tank which is supplied with impure and bad water. Everyone in the village uses it as potable water. As days passed, sickness in the village increases to its peak. The doctors found that half of the village is affected by waterborne diseases. As sickness rises higher and higher, people spend all their money and savings to the hospital for their medical conditions. Poverty rises all over the village. People don't have enough money for food and shelter. Household bills are due. Everyone in the village met the chief of the village for a solution. The village chief came to Team H2O for a solution. We proposed an idea for the problem: water quality monitoring using IoT. Drinking of impure water causes various waterborne diseases. In our day-to-day life, we may also be supplied with impure and bad water. Drinking or using the water without any precautions may lead us to various diseases like typhoid, cholera, etc. Impure water can also make a wealthy place to a poverty surrounded place. In India, waterborne disease is one of the major issues in more loss of life. Hardware and softwares used for water quality monitoring. The Arduino Uno is an open source microcontroller board based on the microchip Atmega 328P microcontroller, and it is developed by Arduino.cc. The board is equipped with sets of digital and analog input and output pins that may be interfaced to various expansion boards and other circuits. The board has 14 digital input and output pins, 6 analog input and output pins, and is programmable with the Arduino IDE. It can be powered by the USB cable or by an external 9-volt battery, though it accepts voltages between 7 and 20 volts. It is similar to the Arduino Nano and Leonardo. A pH meter is a scientific instrument that measures the hydrogen ion activity in water-based solutions, indicating its acidity or alkalinity expressed as pH. The pH meter measures the difference in electrical potential between a pH electrode and a reference electrode, and so the pH sensor is sometimes referred to as potentiometric pH sensor. The difference in electrical potential relates to the acidity or pH of the solution. The pH sensor is used in many applications ranging from laboratory experimentation to quality control. The turbidity sensor detects water quality by measuring the levels of turbidity or the opaqueness. It uses light to detect suspending particles in water by measuring the light transmittance and scattering rate, which changes with the amount of total suspended solids in water. As the TSS increases, the light turbidity level increases. Turbidity sensors are used to measure water quality in rivers and streams, wastewater and effluent measurements, control instrumentation for settling ponds, sediment transport research and laboratory measurements. The liquid sensor provides analog and digital signal output modes. The threshold is adjustable when in digital signal mode. Temperature sensor. DSB18B20 is one-wire interface temperature sensor manufactured by Dallas Semiconductor Corporation. The unique one-wire interface requires only one digital pin for two-way communication with a microcontroller. This is the basic circuit diagram of our project. Let's have a look into our circuit diagram. The positive output and ground of the sensors are connected to the Arduino. For the temperature sensor, the ground wire is connected to the ground of the Arduino. The output wire is connected to the fifth digital pin. The positive wire is connected to the 5V of the Arduino. For the turbidity sensor, the output wire is connected to the A0 analog pin. The positive wire is connected to the 5-volt power pin. The ground wire is connected to the ground pin. For the pH sensor, the positive wire is connected to the third pin of the digital pin. The output wire is connected to the second digital pin. The ground is connected to the ground of the Arduino. The Arduino is connected with the LCD display as per the connections. Three types of waters are collected: normal water, river water, and salt water. The components we are using here are an Arduino UNO and transformer and a pH sensor module. The sensors used here are a turbidity sensor, a pH sensor, and a temperature sensor. The testing is done for river water to calculate the temperature, the turbidity, and pH quality of the water. The next testing is for monitoring the quality of salt water. We have also planned an approximate budget for our project. It contains components as follows. An Arduino Uno costs about 625 rupees, which is 9 US dollars. A pH sensor module kit costs about 1645 rupees, which is 22 US dollars. A turbidity sensor costs about 725 rupees, which is 10 US dollars. A temperature sensor costs about 265 rupees, which is 4 US dollars. The total project value is around approximately 3260 rupees, which is 44 US dollars. Our project is cost efficient. It is portable and it comes in handy. It is also user friendly to use. If people use our product, water quality can be easily identified within seconds and appropriate actions could be taken, thereby preventing waterborne diseases and keeping people healthy and also increasing the peacefulness in the society and reducing the loss due to medical bills, and we can also reduce poverty.